Good morning, dear students. In the previous class, we have discussed about formations of rainbow, primary and secondary rainbow. We also discussed about the dispersions of light, what happened in case of dispersions of light, and what type of phenomenon it is, what are the criteria, conditions for dispersing of light, wavelengths of different dispersed color also we have discussed. We have found that red color has got maximum wavelength and minimum scattering, minimum refractive index. Violet color has got minimum wavelength and it has got a maximum refractive indexes. So today we'll discuss another topic that is also very important for exam, a very simple topic, that is scattering of light. So you please write down the scattering of light. Scattering of light. This is the topic we'll discuss today. You please write down scattering of light. What happened in this case, or what is scattering of light, we'll come to know. So before that, you write the headline of definitions of it. I'm just giving the definition to you first. When light means, you can say sunlight. When light passes through, when light passes through the atoms and molecules of different gases present in the atmosphere, present in Earth's atmosphere, it deflected okay, it get deflected in several direction or in many direction. This phenomena is called scattering of light. Okay, this is called scattering of light. You can note down the definition. When light passes through the atoms and molecules of different gases present in the Earth's atmosphere, it deflected in many directions, and this is called scattering of light. As you know that our Earth is surrounded by a layer of gases. When the light, that means sunlight, will passing through the Earth atmosphere, it has to face, it strikes with different types of atoms and molecules that are present in the Earth atmosphere. Am I clear? It strikes with the atoms and molecules of different gases, those are present in the Earth atmosphere. And once it strikes with those atoms and molecules, it gets deflected in different direction. This particular phenomena is simply called as scattering of light, as I have written here, scattering of light. Okay, so in this case, very simple thing, that sunlight, once it passing through the Earth atmosphere, the sunlight deflected in different direction. By the help of a diagram, we can come to know about this. If I consider that these are some molecules, atoms and molecules of gases, those are present in the Earth atmosphere. So if I consider that this is the sunlight, or this is the light that is passing through the Earth atmosphere right now. In this case, if I consider this is the sunlight or light, this is light, and this light ray is passing through these particular molecules and atoms of different gases. These are the atoms and molecules of different gases. These are present in the Earth atmosphere, and this is sunlight. Then what will happen if it passes through? That these atoms will scattered. Okay, these atoms will scatter the ray of light in different direction like that. Understand? Okay, they will get scattered in different direction. They will scatter in different direction, and these atoms and molecules will behave like a scatterer. Okay, they will behave like a scatterer. That means scatterer are the particles, those who scatter the ray of light. That means these are the atoms and molecules, and this is the sunlight, and this light is passing through the Earth atmosphere. Once it passing through Earth atmosphere means it is passing through the atoms and molecules of the gaseous layer, and then what will happen? These atoms and molecules will deflect this light in different direction. This particular phenomena is called scattering of light. In diagrammatically, you can draw this diagram of scattering of light. Now one more thing that we found, that in our Earth atmosphere, or in this our atmosphere, we find the 7 colors. Those are can be expressed as like that. Okay, starting from red color to violet color. Red color has got maximum wavelength and violet color has got minimum wavelength. Red color has got minimum refractive index and violet color has got maximum refractive indexes. Red colors scatter less, and violet colors scatter most, because its wavelength is less. Its wavelength is maximum, that is why it scatters less. It scatters more because its wavelength is less and refractive index is more. Most importantly, violet color, indigo color, yellow color, all these things are not very sensitive to human eyes. So once you see particularly, what we see clearly, blue color, green color, red color we see. Okay, the example applications of scattering of light is that we see the sky blue. We see the sky blue in the daytime. Okay, we see the sky blue. That is also the that can also be explained, and that is also a reason of scattering of sunlight. And during the time of sunset and sunrise, okay, during the time of sunrise and sunset, we see the sky reddish. That means reddish color we see in the time of sunset and sunrise. Normally we see the color of our sky is blue. These are the applications, for example, applications of scattering of light. I hope you have understood what is the scattering of light. Now there are some laws that all the colors, as I told you, that their wavelength and refractive indexes are less, more, not same. That means all the color present in the atmosphere never scattered equally. Their scattering power, that means that is called the intensity. Scattering intensity is various. Okay, red color has got different scattering intensity, and it has got different scattering intensity. That means intensity of scattered light, intensity of all the scattered light is not equal, and that has been nicely explained by Rayleigh. Okay, that's why you will find a law that is called the Rayleigh's law. You can write down Rayleigh's law. Rayleigh's law. Rayleigh's law. This law, by this law we can understand the intensity of scattered light. Okay, so what Rayleigh told us, you can write according to this law. According to Rayleigh's. According to Rayleigh. Okay, according to Rayleigh, intensity of scattered light, intensity of scattered light, intensity of scattered light is inversely proportional to the fourth power of wavelength wavelength of that light, This was Rayleigh's law. According to Rayleigh, intensity of scattered light is inversely proportional to the fourth power of wavelength of that light. So we can express this as that I, if I is the intensity of scattered light. Intensity means at what rate it's scattered, how much more it can scatter. This is called intensity of scattering light. So intensity, if the I is the intensity of that scattered light, so it will be inversely proportional to the fourth power of wavelength of that particular light. This is I is inversely proportional to 1 by lambda to the power 4. That means intensity of scattered light is inversely proportional to the fourth power of that scattered light, and this is your Rayleigh's law. Something very important you should know. Okay, and in this case there is a condition that the particle, in this case the particles present in the atmosphere, the scattering particle, okay, scattering particle should be less than the wavelength of that light. This point remember, A means the particle, it might be atoms and molecules of the gases, and this particle should be less than the wavelength of that particular scattering light, otherwise this formula will not be valid. Have you got it? So here I is the intensity of scattered light, and lambda is going to be wavelength of that scattered light, and A is going to be that particles, scattering particles who scatter who deflect the light, and this is your lambda, that is your wavelength. Okay, so this is called Rayleigh's law, and you should remember it, very important in the concept of scattering of light. Okay, so please write down, this is Rayleigh's law. After that, I just mentioned you earlier to the class that applications of scattering of light. Applications of scattering of light, or we can find the impact of scattering of light, that why we see the sky blue. It's a question. Why we see the sky blue? Why is the Why is the sky is blue? Why is the sky blue in color? Why is the sky blue in color? Very interesting question. Okay, why it is blue in color? If I consider that suppose this is your Earth's atmosphere. Okay, this is Earth atmosphere, and this is suppose the surface of the Earth, and here this is observers. Okay, suppose this is your observers, and this is your Earth atmosphere, like that. This is your Earth atmosphere. So if I consider this is the sun somewhere, this is your sun. Okay, this is the sun. Now sun, once the sunlight will passes through this Earth atmosphere, then what will happen? All the light will scattered. Am I clear? All the light will scatter. That means when the light reaches to the observer's eye, okay, when the ray of sunlight reaches to the observer's eye, then what will happen? That as I told you that the color settings was like that. Like that. Now can you tell me which color in these settings will scatter more? Obviously this blue color will scatter more, and violet will scatter because but violet is not sensitive to human eye, so this violet color will not be too much visible for human eyes. Why? Because this, according to law, violet color will scatter most, but this violet color will not come reach to human eyes in maximum numbers. Why? Because violet color is not sensitive to human eyes. Similarly, indigo will also scatter in maximum number, but indigo is also not sensitive to human eye. But blue color is most sensitive to the human eye, and blue color has got comparatively minimum wavelength. As the blue color has got minimum wavelength, blue color will scatter most. Am I clear? And blue color is more sensible in comparison to the remaining two colors, that is high in the scattering orders. Am I clear? So blue color will scatter most, and blue color is more sensitive to human eyes. That is why once the sunlight, or once the light passes through its Earth atmosphere, the blue color will scatter more. That is why we see the sky as blue. Have you got it? Blue color, two reasons. So blue color has got more scattering powers. That means blue color will scatter more, and it is very sensitive to human eye. That is why we see the sky blue. Am I clear? Once the sunlight will passes through the Earth atmosphere, blue color will scatter more. Is that clear to all of you? Okay, very good answer of it. And next, one more question, that why we see reddish color of the sky during the sunset and sunrise. Okay, reddish color, reddish color, or red. That means you can write red color of sky is red during sunrise and sunset. Color of sky is red during sunrise and sunset. Why this? As you know that during the time of sunrise and sunset, the positions of the sun is near to the horizon. Am I clear? So if I consider these are the Earth atmosphere, these are the Earth atmosphere, and this is the sun somewhere. Okay, this is the sun. Am I clear? That means when in the time of sunrise and sunset, the positions of the sun is close to the horizon. Remember, during the time of sunrise and sunset, the positions of the sun is close to the horizon. So once the positions of the sun is close to the horizon, during the time of sunrise and sunset, it has to travel a long way. Am I clear? It has to travel a long way. It has to travel a long way in the Earth atmosphere. That means it has got the longest distance in the, it had to travel the longest distance in the Earth atmosphere. That is why once it has to travel longest distance, that means whose color has got the more wavelength, red color has got the more wavelength. That is why since the red color and orange color has got the maximum wavelength, and sun has to travel, the distance between the sun and the Earth atmosphere becomes more. Okay, the distance between the Earth atmosphere and sun becomes more during the time of sunrise and sunset. Then the color of the sky becomes reddish. Why? Because red has got the longest wavelength. Am I clear? Red color has got longest wavelength, and during the time of sunrise and sunset, the distance of path distance between sun and the Earth atmosphere is also long. Then we'll definitely see the reddish color of sky during the time of sunrise and sunset. I'm again wrapping up my classes by telling you that during the time of sunrise and sunset, why it is red color and why we see the sky blue in the daytime. To answer of the first questions, again I am telling you that once the sunlight passes to the Earth atmosphere, blue color is scattered most, and blue color is more sensitive to human eyes. That is why we see the sky is blue. Once during the time of sunrise and sunset, the path distance between sun and the Earth atmosphere is long, more. Okay, and we know that the red and orange color has got maximum wavelength in this color setting, and that is why we see the reddish color of sky during the time of sunrise and sunset. Am I clear? As you can see that if you consider this is Earth atmosphere and this is the sun, this will be the position, that means between the sun and the Earth atmosphere in the time of sunrise and sunset. That means long distance. In the noon it's okay. In the noon time, the distance between the Earth atmosphere and sun is less. That is why it does not travel, maximum distance. That is why blue light comes to us, it's scattered more. Okay, and one more reason that red color and orange color scattered less. That is also one more reason why the reddish color of sky we see when the sun rises and sun sets. I think you have clear these things. It's a very important concept to us. Next class will come with the next topic, that is a microscope. Till then, thank you so much.